Chesterton, the new standard for reliability. Advances in process degreasing. The strides made in the area of aqueous-based degreasing technology over the past decade have been quite remarkable. Spurred on by the impending deadlines embodied within the set of laws known as the Montreal Protocol, researchers have embarked on programs designed to enhance soil removal with the least possible impact on the environment and workers' safety. In this videotape, you will see some of the progress that has been made in terms of bringing aqueous degreasing technology up to the level it stands now, able to effectively replace solvent-based degreasing in virtually all areas of a plant. In days past, industrial cleaners were basically high alkaline, usually highly caustic materials that were used most frequently by maintenance to clean floors and walls so the plant looked reasonably clean. There was very little difference between products because cleanliness was by its nature more subjective. The use of aqueous degreasers on the production line has changed this dramatically. No longer able to use standard methods of soil removal due to the new regulations, process engineers find themselves with a dizzying array of options and decisions to make. Depending on soils and substrates to be cleaned and equipment that is to be used, engineers need to determine the best, most efficient, and cost-effective degreaser for their operation. Surface chemistry. Although there are many other components to aqueous degreasers, surface acting agents or surfactants are among the most important. Surfactants are chemicals which modify the surface tension of a liquid. Some liquids, such as water, have a high surface tension, whereas others, such as ethanol, have a low surface tension. Because degreasers must penetrate and creep under the surface of soils, it is advantageous to lower the surface tension of the degreaser as much as possible. In that way, the detergents, solvents, and other active ingredients in the degreaser can lift, emulsify, and suspend soils, which can then be removed in various bath removal techniques. Let's clarify with a demonstration. The following time-lapse sequence demonstrates the concept of surface tension and demonstrates the difference between three high-alkaline degreasers, two utilizing older technology, the one in the middle, newer technology in surfactants. In the example shown, the products have been diluted 20:1. As you can see, carbon black, a reasonable facsimile of industrial grime, simply sits on the surface of the product on the left. Because the product on the left has a fairly high surface tension, it does not readily wet out the carbon black. The same is true of the product on the far right. The product in the middle, formulated with newer surfactant technology, very quickly wets the carbon black and starts to disperse it into the solution. Another example of the phenomenon, one more common in the production area, is what the product on the right will do to organic soils such as cutting fluids and oils. Shown in this example is a panel on which two circles of a 10-weight oil are placed side by side. Then a drop of degreaser is placed on each. As you see, the product on the right begins to disperse and break up the oil particles quickly. The product on the left simply sits on the surface of the oil. Because cycle time reduction is absolutely key on the production line, the speed with which a degreaser works determines its value to the operation as a whole. Faster is better. High-pressure degreasing technology. Approximately 30% of industry will ultimately choose spray booth washers as their equipment of choice for process degreasing requirements. Older technology products for use in this equipment are powder-based materials. powder tends to leave a residue on parts washed with the material due to incomplete dissolution. Also, these products usually use silicates to ensure that no foam is created. Silicates in the product can be hazardous to workers from a health standpoint, and respirators should be worn when handling the material. These reasons suggest that a liquid degreaser be used. The problem with liquid degreasers, however, is that utilizing effective surfactants, as previously mentioned, lowers the surface tension of the degreaser. As we demonstrated, when surface tension is lowered, the intermolecular forces are broken, which allows the aqueous-based degreaser to spread out and penetrate surfaces. This raises the interfacial tension between the air and the degreaser, which results in the formation of foam. Foam is not a good result with the operation of high-pressure washers rated at 400 gallons per minute. How to avoid this action but still effectively penetrate soils has challenged researchers for several years. Combining surfactants with different lipophilic and hydrophilic characteristics and varying molecular weights has enabled Chesterton to overcome this conflict between too high an interfacial tension and a surface tension low enough to creep under soils. After shaking vigorously for 20 seconds, the product on the left creates high stable foam. The foam in the product on the right, formulated with appropriate surfactants, breaks quickly. The impact of this phenomenon in high-pressure spray booth washers is obvious. Chesterton has incorporated some of these advances in technology into its product line to enable process engineers to efficiently replace solvents on their production lines. The effect is easy to see in the way of cleaner parts, safer products, and faster results in the area of aqueous-based degreasing technology. Let Chesterton put this technology to work for you.